Hello and welcome to this latest video in the OCR GCSE Computer Science series. In this video we're going to be taking a look at a walking talking mock for the November 2020 Unit 2 paper. It'd be really useful if you had a blank copy of the paper in front of you and attempt that as we go. At every point I will stop you and talk you through each question, what you need to do to get full marks and how you can get those full marks in the most efficient way possible. So here are the different topics that make up Unit 2. This is sort of the big picture in terms of the Unit 2 content. The Unit 2 exam could include anything from this page, and if you're taking this exam from this point onwards, it will be made up of two sections, Section A and B. In Section A, you'll be asked to answer some of the questions using OCR reference language. In Section B, you can use OCR reference language or any other high-level programming language that you've studied, for example, Python. So this is an example of the older style paper without those parts, but if you're taking this from now onwards, be aware that your exam will have two parts and you'll be expected to do a little bit of programming within your exam. So here is the first question. The first question asks, or gives you a range of statements and asks you to match up those using their letters. So we've got decomposition, abstraction, input sanitization, and casting, and we need to match up each of those with the relevant answers. This is one of the nice, easy questions to mark. Those are the answers. It's D, B, A, and F. You can write the statements if you wish and still get a mark, but other than that, this is the only way to get the mark. You get 1 mark for each of those, so you've got 4 marks available. Decomposition is breaking down problems into smaller chunks. Abstraction is hiding or removing irrelevant detail. Input sanitization is cleaning up data that's been entered, for example, into a web form for a registration for a website. And casting is converting from one data type to another. Hopefully that's the sort of question you can nail fairly early in the exam. Like I say, there's no negotiation around that one. Those are the answers. Question B is one that my students found oddly tough, and I think it's just the fact that you probably haven't practiced many questions like this one. All it wants you to do is assign the value 7.3 to the identifier timer. And like I said, I think that's a question that maybe the way it's phrased confuses some students. You need to put is timer equals 7.3. So just like we would in Python or another high-level programming language, you want to set that value of timer to 7.3. The mark scheme says not to penalise case, so if you write timer in all capital letters or some capitals, that's absolutely fine, but you have got to spell timer correctly. The final question on this page says state the most appropriate data type for the variable timer. Now we know that timer is storing a decimal value. The answer has got to be float or real. Real is another phrase meaning a float or a decimal number. You could also get marks for the phrases decimal, single, double. Any of those would get you the mark, although float is the one I would be putting. So we've potentially there got 6 marks on the first page. You only needed sort of 9 marks or so to get a grade 1 on this paper, so hopefully you're off to a really solid start. Drew writes the following program using high-level language. So we've there got some pseudocode or some OCR reference language talking through a bit of code. Now the key bit here is that there is a function called newScore. newScore takes in 2 variables, A and B. It times those together, adds 1 to the answer, and returns that answer. So we're being asked what would be printed out at with these various different commands. What's printed out in line 8 for print score? What's printed out in line 9? Print name, but it's important that name is in speech marks. Print newScore score 2. So we're passing the newScore function score and the number 2 as A and B, and then print score. So the first answer is 18. You'll see on line 6 that score is set to 18. So when we print out score, it is just 18. Nothing's changed. Nothing's been made different about the score variable. Print name. Well, name's in speech marks. That's a bit of a trick question. That's going to print out name. Again, you need to be getting that sort of spelt in the right way as it is within the speech marks. Print newScore score 2 is the tough one where people tend to sort of go wrong. So we're inputting into the newScore function score, which we know is 18, and the number 2. So in the function, we times those two numbers together, So 18 times by 2, that makes 36. And then we add 1, 37. So the answer on line 10 would be 37. We then print score again on line 18. Now nothing has actually changed about score. Score is set to 18 on line 6, and that never ever changes. There's no other bit of code that says score equals to change the score variable. Now this is a prime example of a question where you might find the third one difficult, but you should be able to get the marks for the other 3. And getting 3 out of 4 on some of these tougher pseudocode OCR reference language questions is going to be really, really important when it comes to your final grade. Question 2b then asks us about the advantages of writing in a high-level language, so that's something like Python, instead of assembly language, machine code, or sort of binary. Now this is a prime example of a question where you don't need to write too much, but something like easier to use is definitely going to be too vague. You'll notice in my answer I've bullet pointed the 2 acceptable answers. High-level code is quicker to write. So in Python I can put print hello, and that's very, very quick. If I had to write that in assembly language or in binary, that would definitely take me a long time. It's also going to be easier for humans to remember. So the print command word, very easy to remember, much, much easier than the binary or the assembly language equivalent. You could also get marks there for easier to maintain, easier to debug, and easier to spot errors because the code is closer to the English language. This is a prime example of a question where you don't need to write a huge amount, and I would really recommend bullet pointing your answers. Show the examiner that you are definitely making 2 very clear and concise points. C then asks us to describe how a character set is used to represent the string value stored in the variable name. So if, for example, we've got Bob stored in name, how is a character set used to convert that to binary so that it's stored? Now again, that's a 2-mark question. On all of those sorts of questions that aren't essay based, I'd really recommend bullet pointing your answers. Each character is assigned a unique binary value. So each letter is given a value from the character set. For example, the N in the name, if we've got a person with an N in their name, might be looked up in the ASCII character set and converted to 010101 to be stored. So I've got 2 marks there. I've explained what it is, and then I've given an example. And that example is quite important in terms of, well, actually, how is it converted? This is another question where students don't tend to get a brilliant amount of marks. You should know what a character set is. Well, it's a table that allows us to look up letters or numbers and convert them to binary code. So each character is assigned a unique binary value. We then look up the binary value or the letter value, depending on whether we're encoding or decoding, and convert it to binary or vice versa. Question 3 then talks through a vending machine, and a vending machine has a range of options. Part A says explain the purpose of testing a vending machine. This is a prime question where students should be able to get full marks. It should be fairly obvious. Why do we want the vending machine to work? Why do we want the code to be correct? What would the possible problems be if this machine started giving out food at 10% the price it should have been? Gain is 2 marks, so I'm putting my 2 bullet points. Does the machine meet the customer's requirements, and does it work? To ensure there are no logic or syntax errors. It's another one where you don't need to write a huge amount. We want to check that the requirements are met, e.g. all the prices are correct, and we want to check that there are no logic or syntax errors. So we don't want to check if the person's got less than the money required. We want to check whether they've got more than the money required, for example. It then asks you to describe the difference between iterative testing and final testing. Iterative testing is during the development. You might get marks there for saying it's repeated testing during the development. And final testing is normally when the project is complete or almost complete. You can't get a mark for just saying repeatedly testing for iterative. It's got to have something to do with repeatedly testing after or while changes are still being made to the program. So we'd make a change, we'd repeatedly test again. The final part then says complete the following test plan. So we want to test here for some raisins being served with no change given. We want to enter, well, what code do we need there? We want to check the price against not enough money being inserted, and we want to check some sort of invalid selection error message. Here's what you'd be putting. C2 is the input that we're going to need to output raised and served. We just need to look that up in the table. In money inserted, you just need any amount that's less than 50p. So we need to have an error that shows we haven't got enough money for C1, which is Apple pieces, which are 50p. So 49 pence, for example. And C3 isn't in the table, so we need some form of error message that says invalid selection or similar. That's a question you should all absolutely be able to have a go at. What it does say in the mark scheme is that for 49p, we can accept any value less than 50p, but it must be a specific value, not a description. So you can't write in there any value less than 50p. We're then looking at a little bit more pseudocode, and that'll be OCR reference language in the newer exams. We want to give one identifier of one variable used in the program. So you need to look at the code and identify one variable. There's then a little bit of a tough and a bit of a trick question, which is state how many parameters are passed into the give change subroutine. Money is the variable, so we've got money and price that we can. However, there are one parameters passed into give change. Most of you will have put in 2 there because we see money minus price. However, it's the answer of that calculation that is passed into give change. So the correct answer is 1. There is one variable, one parameter passed into give change, and that's the answer of the calculation, money minus price. The answer there is not 2, although at least half of the class will have put the number 2 for that question. Next, we need to draw this as a flowchart. So there's a couple of sort of key bits here. Can you remember the flowchart symbols? And do you read the previous question thoroughly? Do you look at the subroutines, the functions that are being used within that pseudocode? Here's what the mark scheme shows. We've got start, so that needs to be a terminator block with the terminal block with the rounded edges. We've got a then question, is money greater than or less than price? And we're going to output some kind of error. What some of you have then done is rewritten this whole algorithm not using any subroutines. You're absolutely able to use the subroutines that were available within the pseudocode. So we've got vend item and we've got the give change functions, and you need to be using those. And I think you could be putting those in either process blocks or sub-process blocks with the extra rectangles on the edge. We've then got the terminal end at the end. So you get a mark there for checking is money greater than price. So you get some sort of question block. If you've used a decision, a diamond shape, you get a second mark. If you've used the processes, vend item and give money, you'll get another mark. Output, if there's an error, another mark. And have you got the terminator start and end there to get your full marks. Again, that's a question where you should be able to give it a very good go. Even if you get 3 or 4, even if you use totally the wrong shapes, you can still get a decent number of marks on that question. If you can't remember the flow diagram shapes, don't just skip the question. Still give it a go. Put them all in rectangles and you'd still get 4 out of 5. When writing the program for the vending machine, maintainability has to be considered. Identify 2 ways that they've made the program maintainable within the example pseudocode that we were given. We've got 3 options. Indented, they used subroutines, and they used appropriately named variables or identifiers. All of those were definitely in place within the code, so we could get 2 marks for any of those 3 things. Identify one way it could be. It's going to be comments. There are no comments within the code. You could also argue use of constants, which is within the mark scheme, but I think comments is much more obvious within that answer. We then move on to a slightly different question where it's asking you about a little bit of SQL code for 4 marks. Complete the following SQL statement to display the item code for all items that are fewer than 10 items in stock. Select item code from items where stock is less than 10. Again, you're getting a mark for pretty much all of those. Item code gets you a mark. Items gets you a mark. The word where gets you a 3rd mark. And stock less than 10 gets you a 4th mark. Again, if you can't remember SQL, the question gives you a lot of the answers there. Complete the following to display the item code. So select item code. That's given to you in the question. For all items, well, from the items table then, where they have fewer than 10 in stock. So even if you didn't remember the where command word, you could still get 3 out of 4 on that question. The vendor machine is then using a number of states, on, off, or suspended, and they're using something called a switch statement. Now, most of you will have learned if statements rather than switch statements within your programming lessons, and all this wants you to do is rewrite using if statements. I think this is a really nice question because most of the code is the same. We write with our if statements. So we've got new state equals input. That's exactly as it was in the question. But then we've got if new state equals on, then state value equals 1. That's repeated for off and suspended with an else command for print invalid state. That again is pretty much the answer you're going to want for that pseudocode style of question. You want to replace those switch statements with if statements, and most of you will have learned if statements within Python or another high-level programming language. We're then on to a range of different binary and hexadecimal questions. Within the newer exams, you might find that you get some of these questions in Unit 1 instead, but certainly within the 2020 paper, they were still asking the binary questions in Unit 2. We want to convert a binary value into hexadecimal. I'm afraid this is one you're either going to remember the process for or not. If you absolutely don't remember the process, you need to go and watch the hexadecimal and binary lesson that's on this channel. So that is E3. 1110 is 14, which we know from our conversion table equals E. 0011 equals 3, and we know that any numbers from 0 to 9 just equal themselves. So the answer there is E3. You get 1 mark for getting E, you get 1 mark for getting 3. So you might have found the E part harder, but 0011 does definitely equal 3, so it might be you only got 1 of the 2 marks there. We want to convert the denary value 105 into 8-bit binary. Well, what numbers can we switch on? 1, 2, 4, 8, 16, 32, 64, 128 to make 100. Well, we need 64, 32, 8, and 1. That would give an answer of 0110, 1001. As I say, if you're struggling with these questions, you're going to need to go and watch the sort of full video around binary and hexadecimal conversion. It then wants 2 reasons why hexadecimal is used to represent numbers instead of binary. You can't get any marks there for just explaining what hexadecimal is. You also can't get easier to use or easier to understand on its own. You've got to have something a little bit more to specifically say that in the mark scheme. You can get it's easier to remember and shorter to store. You might get less chance of errors on input and easier to convert between binary and hexadecimal. If you've put easier to understand, I kind of get what you meant, but the mark scheme does specifically say you can't get that. It's easier to remember rather than easier to understand. We then need to know what the div and the mod operators are. Div means how many times does 4 go into 13 as a whole number? The answer is 3. 4 goes into 13 3 times. Div is all about division with no remainder. Mod is then about, well, what is, and we've got a remainder there of 1. So 4 goes in 3 times to make 12. We've got a remainder of 1 value left over. Mod is just asking you for the remainder when we do some division. The final question says, show the outcome of a right shift of 3 places on the binary value 0, 1, 1, 1, 1, 0, 0, 0. You all should have got this. You just need to move the numbers to the right 3. 0, 0, 0, 0, 1, 1, 1, 1. All I've done there is moved all of the numbers to the right 3 times and put zeros in any blank spaces. That's only 1 mark, but it's a question you're either going to remember or not. As I said, there is a separate lesson all around binary, hexadecimal, conversion, left and right shifts on this channel. So if you're struggling with that one, please do go and have a look at that separate video. We're then asked about some logic gates, and it wants us to draw the logic diagram for the logic system P equals A or B and C. So first of all, can you remember the shapes? Because it does say the shapes must be accurate within this answer. The AND gate looks like a big capital D. The OR gate looks like a shape with a huge capital R sort of drawn, taking a chunk out of it. This is what you should be drawing. B and C go into the AND gate because we know we've got that in brackets and we know that the things deepest in brackets must come first. The answer from B and C goes into an OR gate with a new variable called A. You can get 3 marks for that. If you've got B and C, so B and C going into any kind of AND gate, you get a mark. If you've got an OR gate with any 2 inputs, one of which is A, you get a mark. And if you've correctly connected the gates up together in this sort of structure, you can get that answer. It's also asking us to complete the truth table for the system, not A or B. So an OR gate means if A is on or B is on, the answer is on. However, that goes through a NOT gate, which reverses the answer. So in the first row that we need to fill in, we've got a 0 and a 1. That would equal a 1 because one of them is on. But we've got to opposite, we've got to reverse it because it goes into a NOT gate, so 0 in the first column. 1 and 0 again, well, that's exactly the same, isn't it? It's a 1 and a 0 going in, a 1 comes out, but we reverse it to make a 0. We've then got to work out, right, what number haven't we tested? A truth table should test all of the potential combinations. So we've got 0, 0, we've got 0, 1, we've got 1, 0, so the next inputs for A and B would have to be 1 and 1. A 1 and 1 from an OR gate, again, means a 1 comes out, but we want our NOT gate, so it's a 0 that would come out at the other end. The following logo is stored as a bitmap image. Each box represents 1 pixel with 3 different colours being used in the image, and we've got the really creative OCR logo there. State what is meant by the term image resolution. Should be fairly straightforward. It's the total number of pixels that make up an image. You could get a mark for saying it's the height and the width in pixels, and actually what we do is multiply those 2 values together. You can't just say the height or the width because that's not actually what resolution means. A tough question then, which a number of you got wrong, either because your maths wasn't very good or because you didn't work out the bit depth of this image correctly. Calculate the fewest number of bits that could be used to store the image as a bitmap image. Our first mark is working out that there are 90 pixels in total. So we've got 15 pixels wide by 6 pixels high, making 90 pixels in total. Lovely, we've got a mark. We've then got 3 colours. A number of you put that the bit depth was therefore 3. It's not. To store 3 different colours, we need a bit depth of 2. That means each pixel has got 2 bits stored within it to allow us to store black, white, grey, and we'd be able to store another colour if we need it. So we've got 90 pixels, each of them are storing 2 bits. The bit depth is therefore 180 bits. You're getting a mark for every line there, and a final mark for 180 is your overall answer, getting that maths right. For example, if you multiplied 90 by 2 and somehow got the answer wrong, you could still get 3 out of 4. Give 2 ways that the image size. Well, we could reduce the resolution, we could use lossy compression, we could use lossless compression, or we could reduce the number of colours and reduce the bit depth. Any of those things would definitely reduce the size of that file down. If you got your maths correct in part B, you should better work out fairly quickly, well, how could I lower that number? I could lower the pixels, or I could lower the bit depth, and that would then make the bits in question B a lower amount. Metadata is sometimes stored alongside images. State what is meant by the term metadata. Well, metadata is key data stored about the file as part of the file. We might store things like when it was last edited, for example, who the author was. With an image, we've got things like the height and the width and the bit depth because we know we need that to recreate the image. It says give an example of one piece of metadata we might store about the image. Well, we're going to need to store the height. You could have their height, width, color depth, resolution, geolocation, date, time of creation, date, time of last editing, file type, author details. It does say do not accept the file name, so the file name would be stored elsewhere. Again, if you knew what metadata was, you probably got the second question. If you didn't know what metadata was, you probably didn't. The following names of students are stored in an array with the identifier student names. Describe the steps that a linear search would take to find Anna. Now, the mistake that most of you made here is you did a brilliant explanation of what a linear search was. That's not what it asks at all. What it's asking you in the question is how would we find Anna using a linear search for 4 marks? So you need to make 4 points. Lots of you got 2 out of 4 on this question, but didn't nail the full 4 mark. We want to compare Anna and Rob. 1 mark. We know that a linear search goes through the list in order and it compares every item to Anna. Compare Anna and Rob, not equal. By saying not equal, you get your 2nd mark, and that's where a lot of you have missed out. We then compare Anna to Anna, and it does equal that, and we print the item found. So you've got 5 marks you could potentially get there, and you could get any 4 of those 5 marks. You've got to be specific though. It's got to be this list, and it's got to be the phrase Anna we're looking for. Don't explain a generic linear search, because that's not what the question has asked. We're then asked for a insertion sort with the names on the list. Now, an insertion sort uses a sublist within the existing list. It doesn't create a new list. As it does the insertion sort, the computer keeps track of, right, which blocks are sorted and which aren't. So in our first row, we need to put Anna at the start. We insert Anna, which should be the first item in our list, into the correct place. So Rob is already in first place. We then take Anna and we insert Anna into the first location. In the second row, we then take the next value, which is Hugh, and we insert that, and the ordered list becomes Anna, Rob, and Hugh, with those first 3 values. We then take Emma, which is the next value from the original list, and we insert Emma. So we've got Anna, Emma, Hugh, and Rob, and the computer knows that that is the ordered list. We then take Patrice. We take Anna, Emma, Hugh, Patrice, and Rob, and that section of the list is then ordered. Finally, we insert Iqbal, giving the final list and the final row. Now you get 1 mark for each of those answers. The mistake that some of you made is thinking that an insertion sort inserts the values into a totally new list. So we'd only have Anna in the new list and the rest of the cells would be blank. Then we'd have Anna and Hugh with the rest of the cells blank. That would be incorrect. You've still got the whole list, but the computer keeps track of the ordered subsection of the list. Again, I don't think I've done a particularly good job of explaining that there, so it might be that you need to jump on and have a look at the insertion sort lessons, of which there are lots available on YouTube. You've got 5 marks available there, so if you drop a lot of marks on this question, you may well find yourself dropping down a grade boundary, so this is one you need to give a good go at. We're then on to the final question of the November 2020 paper. It says, a school uses the array to call an attendance register every morning. Write an algorithm using iteration 2. Display the name of each student one at a time from student names. So we need to loop and print out all of the names in that list. Take as an input whether the student is present or not. So print, are you present? Response equals input. Display the total number of present students, so we need to keep track of those in some form of way. This is a tough question. The last question is always going to be a hard one. It's probably going to be a pseudocode or an OCR reference language question. You're probably going to find it hard, but please give it a go. One of my students got 1 out of 6 on this question, but it was the 1 mark they needed to go up to the next grade boundary. The model answer from the mark scheme. We need to set present and absent to 0. We then need to have some kind of loop. It says in the mark scheme you get a mark for any kind of loop. You could put any kind of while loop, any kind of for loop, and you'd get a mark. Print the current student names, so they use I to loop count. For I equals 0 to student names.length minus 1, so from the start of the list to the end using I as a loop count. Print student names I. So the first time through the list, I is 0, so it prints the first item from student names. The second time through the list, I is 1, so it prints the second item from student names. The third time through, I becomes 2, and it would print the third one. Ask are they present? I'm going to get a mark for that one. And if the response is present, then increase the present count by 1. But if the response isn't present, then increase the absent count by 1. And again, we're getting a number of marks just for saying present equals present plus 1, absent equals absent plus 1. At the end, do you output the present and absent values? Print the number of present students is present, and print absent the number of students is absent. You could literally only put that. You could put print present equals present and print absent equals absent, and you'd get 1 out of 6. Like I say, for some of you, you might find that's the difference between a 5 and a 6 or a 7 and an 8. In these tougher pseudocode questions, you've got to give them a go. You've got to get the basic code in, even if you're not thinking you're going to get full marks on the question. Hopefully that's been a useful run through of the Unit 2 November 2020 paper. The November 2020 paper for Unit 1 is also available on this channel, so if you have found that one useful, please go and have a look. Good luck in your exams.